Now, let's talk about reentrancy attack in blockchain and how we can prevent it. First, we are going to talk about what is reentrancy attack. Second, how reentrancy attack work. Third, checks FX interactions pattern, Mutex, and finally RiseIn. Let's start with what is reentrancy attack. A reentrancy attack exploits a vulnerability in a smart contract that allows an attacker to repeatedly call a function before the previous call has completed. This can lead to unintended consequences such as manipulation of contract balances or bypassing security measures. How reentrancy attacks work. Here we have two contracts, contract A and contract B. In contract A, we have three functions. First, we check balance, then we send the funds based on our check, and finally we update the balance. But what if contract B calls back into contract A before it is done updating balance? What happens then? We would be sending funds again based on the previous balance check, which would be incorrect at this point. That way, we can drain the funds from contract A. So let's see how we can prevent it. Our first method is checks FX interactions pattern. Checks FX interactions pattern involves performing checks and updating contract state before making external calls. This prevents the risk of reentrancy attacks. Here we have an example. In this example, we have a function called safe withdraw and we are having a parameter with name amount. Here first we are requiring amount is smaller than the balance of the message.sender so they can withdraw their token. Next, we are withdrawing balance, here subtracting the amount from the balance of the message.sender, and here we are performing checks FX interaction pattern. After this call here, we have a tuple return, but we don't care about the other parts, but we care about this first variable here, which we called here success. If our call was successful, then this variable returns true, if not, then returns false. After this call, we are making the check here to see if we were able to make this call and send the funds to the user. So this is called checks FX interactions pattern. And we also give the amount here with the value and we tell how much we are going to send to the user. Next, we have Mutex. Mutex or mutual exclusion can be used to prevent reentrancy attacks by locking critical sections of contract code. Mutex implementation example. Here we have a contract and we have a modifier here. As you remember, modifiers work in this way. First, we have the code in the modifier, then we have this line. This line means that we are going to integrate the function code to here. Since this is our function here, our code will be this function's code. Then we have our final line here, then our modifier ends. So we can say modifier is inclusive and it contains the function that is using it. Here, if we look at it, we have a locked boolean, and in the beginning we are requiring it to be unlocked. So we are requiring it to be false. And then we are locking our function. After the function execution here, we are unlocking. If there's a reentrancy attack during this, since our locked is true and we require not locked, which means locked is false, then we will be able to prevent attacks this way. This is another method called Mutex. And finally, we have RiseIn. RiseIn involves using a modifier to prevent a function from being called again before it has completed. RiseIn's implementation example. Here we are using RiseIn from OpenZeppelin contracts and under the security. We are saying our contract is RiseIn so we can use its functions and methods. And in our function, we are saying this is non-reentrant, and this way we can use the RiseIn's protection. So we are doing what we did with the checks FX interactions here, but we are also adding this line for extra security, which is implemented for us by OpenZeppelin. That's all for this video. Thank you very much, and I will see you on the next video where we implement our logic based on this.